on 6-8, couple of reminders before we jump in. Again, if you haven't grabbed your graphing calc, make sure you grab one. When we're looking for mins, we're looking for valleys. Okay? We're looking for where the graph comes down and then starts to go back up. If it's the other way, where it's more like a hill, that top point. So it was heading up, and it heads down. Okay, that's a maximum. Those things are going to help us with interval notation to figure out where my graph is increasing or decreasing. And then just one last reminder, you always want to use x values when you're thinking about interval notation. And I'll stress that some more when we actually get there. So, this is calculator, calculator, calculator. And as I've said before, if you don't literally have one of these, today and tomorrow will be some good days to kind of play with it, get used to it, do your homework, that type of deal. So, what we're going to do is we're going to go ahead and we're going to graph this. Okay, so I've got it typed in on my calculator already. Be careful that you are typing in your polynomial carefully, because if it doesn't go in correctly, you're not going to get the right answer out. So once I've got it typed in, I'm going to graph it. So I want to get an idea of what this looks like. Well, this looks kind of funky. Now, I don't just want to straight sketch it right away. That's not necessarily going to help me out a whole lot. So what I want to do is sort of like what we did yesterday. And if some of you even wanted to get a piece of graph paper for this, instead of kind of playing this way, that's okay too. But we're kind of just sketching. Let's see if we get any zeros right away. If we don't, we're going to mess with this. We'll play with it. We'll make it work. Okay, got one at 0, 0. But it looks like that's the only one I'm going to get lucky enough to have. That's going up. That doesn't do any good. Okay, so that's the only one of those I get. So I start to look at the graph, and again, I'm looking for, yes, I do. I've got some over in there, but I got some here too. So what we're going to do is we are going to notice that we have a min down here towards the bottom. I know that one for sure. So, in review, to find the min, we are going to hit second and then trace. That's going to bring up our calculate chart. And since I'm looking for a minimum, I either hit 3 or I can arrow down to it and hit enter. And then this whole left bound, right bound thing starts. So remember, we're trying to trap it. So my little cursor guy needs to be somewhere on the left of this point that I'm trying to trap the bottom. So like if I have him here, that's fine. I hit enter to lock the spot in. Once I do that, now I need to trap it. I need to have him show up somewhere on the right side. Again, doesn't matter as long as it's somewhere to the right of this point. I hit enter twice, so I really don't need to guess. It's going to help me out here. And it tells me that the minimum is at negative, oh, if we even go to a tenth, that's okay, negative 1.2, negative 3.2. So I'm going to plot approximately where that would be. So then I'm starting to wonder. I'm like, I really can't see right in here what's going on. It's kind of all squished up. So how can I do that? Now, I could just mess with the window. But there's a faster way of getting there, and you're really going to be able to see how it works. So here's how this one goes. If you hit zoom right in the middle up here at the top, and say you want to zoom in, this is kind of cool. Your little cursor guy now becomes free to go wherever you want him to go. So if I want him to go up about where, zoom in a little more here. Okay, there he is. He's still moving around. Just up in this area in here somewhere, so I can see what's going on a little closer. Once I get him up in that area and I hit enter, it'll mess with the window and do everything for me. So now I start to look at this, and I'm like, okay, this point that I can't see down here anymore is the min that I just had. So I start to look in here. And I look and I go, you know what? I don't think we're going to have any sort of value going here. It looks like it just keeps going up. So by zooming in, I can visually see what's going on here, that I'm not going to end up with a min. You're like, well, how do I check? If I wanted to check to see if there was a minimum, because it might dip down a little bit, I could still hit second and trace, just like I did before. And I could still test this to see if there's a minimum in here. So I'd kind of be okay. Somewhere to the left of this little area. Let's get a little more. Somewhere to the right. And again, how far you want to go to the right, that's fine. So let's look and see if we get a min. Ooh, we found out we've got one in the place that I didn't think it was going to. Oh my. That might be even worse than the first hour boo-boo I made. Which one do I want to put online worse? Yeah, you're going to get to see my balding head. Okay. So, I do end up with one more small min in here. Oopsie. Now, to get back out of this, because I don't want to be this zoomed in forever, especially not on my head. Yes. I'm going to go and I'm going to put my calculator back to its normal -10 to 10 on these. And you can, depending on, here's the thing that gets a little tricky with this. Let me bring this back up and then let me explain what could be happening. Depending on exactly where you zoom, you might be tweaking. Are you tweaking hugely different from me? Because there's about a 1/10 error that can come one way or the other depending on where you zoom. So some of these are a little bit closer for comfort than I would like, that are going to make them a little trickier. Oh, I'm sorry. So if you have one, you can use that one you have instead of mine, because there's this very small error you can get into with some of the details sometimes. Because what we're going to do, it's going to be kind of tricky to see, but we'll make it work. Again, we're getting that approximation. And again, if your second min's a little bit different from mine, that's not going to throw us off here. What's going to end up happening is, sort of like what we did yesterday. We move this out of the way. As my graph is coming from the left, it's decreasing in value. So I'm just going to kind of mark it this way. As it starts to go back up, it's increasing. And we're going to have the littlest of points, which is why I chose this problem poorly. That very little dip down to the min, which you're barely going to be able to see. And then we're going to keep going up. So when it comes to the interval notation, and again, I would not put one this nasty on a quiz. What I'm going to end up doing here, so I have decreasing, and I have increasing. I'm decreasing, again, only x values I'm using here. So my x value is coming from -infinity. This keeps stretching outward. So from -infinity until my first min here. And I'm just going to put its x value here to remind me. So from -infinity to -1.2, because I'm coming from the left, because remember, x values I'm looking at. As I'm coming from the left, I'm coming from negative infinity. That's the tricky part with these, because you're starting to think why, because you're looking up and down. So from there, though, now it starts to increase. So from negative 1.2 up to our spot where we're getting in here again, okay, we're increasing. And we have this little dilemma in here, which I will come back to. Because now what you're looking at is, you're like, well, wait a minute. What happened in this little gap in here? Because I can visually tell you if my min was here, it's going to be increasing from 0.16 to infinity. What happened in here? Because there should be a decrease point. Sometimes with these, they get so small or minuscule. That's why some of you were getting different values in here. There's this tenth of a place about that can happen with these calculators that are a little bit, I don't want to call off, but I'm going to. Because basically, your calculator is going to look at it as though that's increasing the entire time. So if you run into one of those little tiny ones, which I don't think we're going to get another one of those here, don't worry about it. Just let it keep going on an increase for you on that one. It's just one of those things that the higher you're going to get up in math, the more tricky this issue is going to become. And I kind of put one in there that didn't work real well. And I wanted to make sure I did that one with you. I want to do one null that's going to be normal. You're like, really? There are some normal ones on here? Yes. Yes, there are. And 2 is actually one of them. 2 is a little more realistic as to what we may see on a quiz here. So let me keep this up. Let's rev this one up and ready to go here. X squared minus 2. Let's start seeing. Okay, normal old parabola. Thank goodness, something is normal. Keep that on the screen. May have to zoom back out here for a moment. Yep. So we can actually get everything in here. Okay. So what do I notice right away? Do I have any maxes? Do I see any hill-type shapes? No. I see a valley down here, though. So I want to know where that is. So I'm going to go to my minimum screen. Okay, so my second trace, down to minimum. And I got to trap that lowest point in. So anywhere over here to the left, I'm going to hit enter. And then I'm going to arrow over until I'm on the right side of it. And I'm going to hit enter twice because it does that guess thing. And like we mentioned yesterday, anytime I see E, that automatically means that value is 0. So I have a minimum that's 0, negative 2. And since all I'm trying to do is figure out the interval notation of this, if I wanted to, I could go find a 0 so I could know what one of my intercepts was, because we know since this is a parabola, it's going to be symmetrical. So anywhere to the left or above my x-axis, I could hit an enter. So I'm doing the zeros. And anywhere below, which would be to the right of that point. And what I would get is my 0 is at about negative 1.4, but since any parabola is going to be symmetrical, I'm also going to have 1 over on the positive side. Draw my parabola in. And now this one's a little easier to look at as far as decreasing and increasing. It's coming down until it gets to my minimum. And it's going to go straight back up. So not a whole lot of movement this time. So what would be my interval for the decreasing portion of my graph? Negative infinity until I hit 0. And then it starts back up at 0 for my increase and heads off forever to the right, positive infinity. Okay? They can actually be simple sometimes. They're not always going to be a huge old pain. And then I knew 4 would end up being a problem spot, with some, especially with the big old numbers here. It doesn't actually end up being that bad, but we'll give it a go here anyway. Scooch back over for a sec here. So when we're doing this, back to y equals. When you're typing in this negative x to the third, you have to use the negative button next to enter. You can't use minus or it won't graph for you. So make sure you get the little shorter negative sign there. Plus 13x squared minus 56x plus 81. Graph that. So let's see here. Okay, kind of looks like a funky looking hyperbola. It kind of goes and twists down. So here's what we have to worry about. I think it just kind of comes by and goes down, but I'm not sure again. So again, I'm going to zoom. Got scary the last time we zoomed, but we're going to do it anyway. So we're going to zoom in. So zoom in number 2. My little cursor guy, there he is. I'm going to work my way over, and I'm going to set him in just below where I'm looking at, over here in this area. So I've got him right about here. As long as you're in there, again, that 10 thing might come up again, but let's see. Now this one makes a little more sense, because now I notice by zooming in closer, that looks like that's going to be a min, and this could end up being a max up here, because it goes up a little, not a whole lot. So once I get that part, looks like I may have one of each. So let's see here. So I'll still do second, and I'm going to go back to trace, because I have to get my calculate menu up. And what we're going to end up doing here, we'll go ahead, we'll look for our minimum first. We're looking for our valley, as far as that goes. So we're going to scroll back to the left here, where it looks like my minimum is going to end up. But again, since I'm trying to trap that point, I want to make sure that I get it moving over to the left. So anywhere to the left of my supposed minimum here, we'll go ahead, we'll hit enter. Then we got to go to trap it, make sure we clear it somewhere here to the right, because now I'm going to be trapping that area in. If I hit enter twice, let's see what we end up with. Let's see if we get the same thing this time. Basically, we're looking at 4, 1 if we round. Are we getting any other weird decimals like we did on the other one? Right, and you may get all the zeros with your decimal on the other side. That's still okay, rounding-wise, we've got the same thing. I just want to make sure that we're getting the same. We're getting that same value. Like, I'm going to take silence as approval. Your calculator is acting weird. Let's see it. It is weird. All right, let's check out the weird calculator here. That's the third plus 13x squared. Oh, weird. Oh. Here, just for fun, let's check this out for a minute. Check this window out. We're up in we're used to negative 10 to 10, and we're looking at like negative 38,000. Somebody was having some fun earlier today with this, it looks like. Oh, that's gonna look much better now. All right. Anybody else with strange calculators that we want to take care of? Oh, we do have one. Okay. Keep them coming. See, this is good. So you can all be the experts now. When you come in and one of your buddies' calculators gets screwy, we can fix you. Yes, ma'am. All right. Let's see what we got going this time. Now, this one looks normal. Negative 10 to 10. Let's see what's happening here. Go back to y equals. Good. That was too close. Is that what you're trying to tell me? All right. Is this happier for you? All right. I know. Well, because I need to be able to see the problem. So I want to make sure we're okay here, because any rebel calculators will be dealt with. All right. So now we're ready to get zoomed up here. Any others? I'm ready for all comers. Okay, let me reset here for a second. Let's make sure we know how to do this. Because I'm not telling you need to randomly know how to get these decimal answers. So let's reset. Okay, here's our graph at normal. At least we hope, there it is. Okay. Kevin, give calculator back so she can figure this out. Thank you. All right, no, don't zoom forward. Now, if you want to take a closer peek, because our deal before was we weren't sure if we had maxes and mins in here, if it was just, a smooth sail. So if I hit zoom, okay, so right under the format here, and I want to zoom in like a camera would for a close-up, my little cursor at that point becomes available. I can put that cursor wherever I want to. And what I want to do is I want him close to that point where I'm trying to test. Anywhere in there. So if I was a little below, that's okay. A little above, that's fine. And I'm going to hit enter, and it'll do all of the work for me as far as zooming in. Because then, now since we've found that minimum, if I want to go back and do second trace, I can try to find my max. I would say zoomed in. So we're testing out about that point where the blinker is at, about where my cursor is at. And again, I want to make sure that I give myself plenty of space to check. So anywhere to the left, since it says left bound, I'm going to hit enter. Right bound anywhere to the right. Err on the side of giving yourself too much room. And 2 enters. See, do we get a max? We do. So we've got a max at 4.7 and about 1.1 here. So let's get zoomed back out then. So get your window back to our normal, which is our negative 10 to 10 on this. Because now we're going to sketch this, now that we've got the information that we need. So we've got him back. Shift over here. So now when I go to draw, again, I just need a sketch on this. So I've got a minimum value at 4.1. And I have a max at 4.7, 1.1. So it's not a whole lot further up. Okay. Again, I'm going to sketch what I see. There's my min. It comes up to a max and then heads back down again. So my actual part of doing this now, my interval notation for increasing and decreasing, now that I have my sketch, remember, if we go to colors, that's going to help. Because if I move this out, I can see that my graph is decreasing as it comes in. Then it increases for just a little bit. And then it decreases again. So visually being able to see that and see the x value at my min and my max should help me visualize how this is going to work. So as you may notice, I have 2 different areas that it's decreasing this time. What's my first area? How would I write that as far as interval notation goes? Okay, negative infinity up to 4. So anywhere from over here down to this point is decreasing. But then it starts to increase again. What's my interval in my little increasing spot? Okay, from 4 to 4.7. And then it goes right back to falling off the face of the map here. So what's my last decreasing interval going to be? 4.7 to infinity. So it does take a little bit of time. I still need my minimums and maximums. But it lets me kind of play with this a bit. So it kind of like, I got 3, then you've got 3 to work with. The only other thing I want to mention, zoom back out here a little bit, is as we flip over to the back, writing polynomial functions of least degree with integral coefficients sounds real big and nasty, but it's not. Remember, these zeros are just opposites. So when I write my binomial terms, I'm just changing the signs on these. So change my positive 3 to negative 0. There really is not an opposite. So remember, we were pairing these off before. But one question before we pair off. What's x plus 0 going to be? Oh, I heard it. X. If I add nothing to x, I still have x. Okay? So here's what this looks like as I prepare to expand it. Now when you go to expand, you could distribute the x first and then multiply it out. You deal with these two first. Okay? Here? No, it's, oh, I'm sorry, I see what you're saying. Nope, that still should just be a regular parenthesis, just a regular quantity. So when you're here, you can FOIL. I know some of you are comfortable with that. You can also, like we have before, you can box it, which is a good organizational tool that you could use when you're trying to make sure that as you multiply these out, you're combining your like terms. But just remember, even when you combine your like terms here, in your diagonals, don't mess with the exponents anymore. And the other thing I have to remember to finish this one off is, this is only these two. To finish it, I've still got to distribute my x through. Because knowing that there's 3 answers, I should get a degree of 3 out of this. So when I distribute, I've got x to the third minus 2x squared minus 3x. I now have my cubic because I have 3 solutions. That's how all of these up in this upper part are going to work. Last thing, and then I'll let you go on your own and I'll kind of help out here. Down at the bottom, remember, we wiped out 12 through 14. And I'm actually going to work through 11 with you as a reminder. Because as we were doing the homework, I noticed some of you are forgetting one little portion of this. So I want to use this kind of as a reminder. Whenever you have I as one of your zeros, they come in pairs. So if I have I as one of my zeros, negative I is going to be another 0. If 3I is one of my zeros, negative 3I is going to be one of my zeros. And you're like, I got to do this 4 times? Well, let's see. If I write these out, I have x minus I. So again, I'm changing the signs. X plus I. And the same thing with my 3's. X minus 3I. X plus 3I. And whenever you're doing i's, you want to pair off the ones that are paired, because then the I is going to go away. So for example here, if I'm looking at my 3 i's over here, again, if you want to FOIL, you can. I like the box because it's organized in me. So x minus 3i, x plus 3i. When you multiply this out, and don't let the fact you're seeing two things that look like variables scare you here. So I've got 3ix, negative 3ix. Then we'll get to the review part. We're going to see what to remember. When I go to combine my like terms, once the box is filled, these two boxes are always going to cancel, which is a good thing, because I can't have I in my answer. What does I squared equal? So if I squared is negative 1, what's this box going to equal? Positive 9. So this is x squared plus 9. I do the same thing over here. So you're like, okay, so if I go to do it on this side, and work through same deal. The plain old x terms are going to cancel out. And what's my final box in the corner going to turn into? 1. That's the opposite of negative 1. So this is x squared plus 1. And your final job then would be to box those two. Then you're done. So it's actually 3 times I got to do it. But I have 4 zeros, so I have to get something that's a 4th power polynomial. Mercy. So, your task, 8, 9, and 10 up above, you got to multiply them still. Yeah, there's one more step still. So one more box to come. Yep, one more box and that one's done. So 8, 9, and 10 at the top, 4, 5, and 6 on the front. Tomorrow and Thursday, we're still going to be in work-through mode. So if you still need time to finish this, or the 6-8 homework, if a calculator's an issue, no fret, there will be time tomorrow. Because Thursday will be our sit-down. Oh yeah, I forgot to mention that. Let me pause.